Hello, mathematicians. Welcome back to another day of math. Make sure you have your math journal ready to go. And as you notice today, I've already got my place value charts already set up because I know I'm going to need some place value charts today. So let's go ahead and get started. Today, we are going to be composing and decomposing numbers, representing them using standard form, and expanded notation. In yesterday's lesson, we did compose and decompose numbers. We composed and decomposed their values. Today, we're going to be extending that to representing numbers in some new ways. We see here standard form, which we did do yesterday, expanded form, and expanded notation. So get ready to work with some large numbers today. Let's take a look at the different forms that we're going to be representing numbers in. First, we have standard form. Standard form is just the way a number is written using the digits 0 through 9. So it's just the way we normally write a number. Here we can see the standard form of a number, 31,425, is written with the digits. The next form that we are going to be representing numbers in is expanded form. You may remember expanded form from second grade. Expanded form is where we decompose a number showing the value of each digit. Yesterday we worked with digits values. So today we are going to be taking those values, writing them out in numeral form, and then using our addition, our sum of, to write out the expanded form of the number. So each digit, we're going to label its value, and then we're going to add those values together to represent the number. Here we can see that the digit 6 is in the 10,000s place. That digit 6 is not worth just a 6. He has a value based on his place, the 10,000s place. So the value of that 6 is actually 60,000. 60,000. And then here, our digit 4 is in the thousands place. So he's not worth just 4. He's worth 4,000. We have a 2 in the hundreds, so that would be worth 200. 7 tens has a value of 70. And 5 ones has a value of 5. So he is just a 5 because he's in the ones place. And when we add all those values together, 60,000 plus 4,000 plus 200 plus 70 plus 5, do you know what we get? We get our number, 64,275. So that's expanded form. Now let's try that in some questions. Here we have our first question. A number is represented in expanded form below. 40,000 plus 3,000 plus 800 plus 2. What is this number in standard form? So when we see these values here, do you notice anything interesting? Anything you need to watch out for? Notice our caution sign. We have a sneaky 0 again today. Can you tell which place is missing from our values? Take a close look. Maybe use your place value chart. You think you have an idea of which place is missing, where we're going to put sneaky 0? Well, let's use our place value chart, plug in our digits based on the values that we are given here, and see what number we make and where that sneaky 0 ends up. So let's start here by looking at our strategies. We've drawn our place value chart. We're going to plug in our digits based on the values that we have. Our first value is 40,000. 40,000. What place would this 4 be in if it's worth 40,000? 10,000s. 10,000s. So we're going to put our 4 in the 10,000s place. Next, we have a value of 3,000. Where would that 3 go on our place value chart if the value is 3,000? The thousands place. Good job. Don't forget your comma. Next up, we have a value of 800. Where does that 8 go for 800? Hundreds place. Excellent. Then we have a 2, baby 2. Where does baby 2 go? He's ones. That's 2 ones. So here's our ones place. Did we find out where sneaky 0 is? Yes, we did. The tens place. Do we have to plug in a 0 there? We do. If we don't plug in a 0 in the tens place, then it changes the value of our number. Our number would become 4,382, and that's not the values that we have. So yes, sneaky 0 does matter. He holds that place. All right, so now let's rewrite our number as we say it out loud. 43,802. So here we have the standard form, our number written with the digits. So now we need to see which answer choice has a number that matches our number. Look at them closely. Sometimes the digits can look similar, so look real close at every place. Can you tell which one matches our number in standard form? Did you say C? Let's double check. Let me get out my pen. Let's double check. We have a 4 in the 10,000s. Yep. A 3 in the thousands. Yep. An 8 in the hundreds. Yep. Sneaky 0 in the tens. And 2 ones. Yes, that matches our number. C is the correct answer. Well done. Let's try another. What about this type of expanded form question? 45,729. Which shows this number represented in expanded form? So this time we're doing the opposite. This time they gave us the number and we're having to decompose it, break it apart based on its value to represent it in expanded form. So let's take a look at our strategy. Draw a place value chart. We've got one ready. Plug in our digits, then write the values, and then use little checks and little X's to process through the answer choices. Look at our caution sign. Interesting. Sometimes you have to combine values if they are from the same place. Well, that's interesting. I wonder if we're going to run into that with this question, combining values that are from the same place. Well, let's get started. First thing we got to do, plug in our digits. So for 45,000, we have 4 in the 10,000, 5 in the thousands, don't forget our comma, 7 hundreds, 2 tens, and 9 ones. Since we're trying to decompose this number into expanded form, we need to break it into its values. So we need each of these digits' value. So let's look at our first digit, our 4. Is he worth just 4 if he's in the 10,000s place? No, definitely not. He's worth a lot more. 4 10,000s would be how much? Let's skip count it. 10,000, 20,000, 30,000, 40,000. So I'm going to write 40,000. He's worth 40,000. Now let's write the value of our 5. He's not worth just 5. He's in the thousands place. How much is he worth? What is his value? 5,000. 5,000. Next up, 7. He's in the hundreds, so that would be 700. How much is 2 tens? Skip count it. 10, 20. That 2 is worth 20. And then our baby ones. How much is 9 ones? Well, he's just 9. Baby ones. All right, so now we have our value. So now we're ready to write it out in expanded form. So let's come down here below our place value chart and let's write it out. 40,000 plus 5,000 plus 700 plus 20 plus 9. So there's our expanded form. Now that we've done our work and our thinking, let's use little checks and little X's to process through these answer choices. So let me grab my pen. All right, here we go. Let me scoot him over. There we go. All right, let's look at A. A starts with 40,000. Does our expanded form have a 40,000? Yep, check. 5,000. Do we have 5,000? Check. 700. Ooh, this one's looking good. A 2. Do we have 2? No, we have 20. And look here, a 2 and a 9. Are those values from the same place? They are. They're both from the ones place. So we could put them together. What is 9 plus 2? 11. And we don't have 1 10 and 1 1. So this one got messed up at the end. So it's not A. Bye-bye A. Let's try B. 40,000. Yep. 5,000. Yep. Do you notice something interesting here? A 400 and a 300. Are those from the same place like our caution sign warned us? 400 and 300? Yep, it's from the same place, so we need to put it together. Do you know what 400 and 300 is? Think about 4 plus 3. 700. So this is actually, when we put it together, a 700. How cool. And does our number have a value of a 700? It does. It does. So that's a check. 20. Do we have 20? Yep. And do we have 9? Ooh, got all little checks. So we think we like B, but are we going to stop? Nope, a mathematician does not stop. A mathematician processes through all the answer choices. So we have to keep going. 4,000. Well, this is the thousands place. Do we have a 4,000? Nope, we don't. We have a 40,000, but not a 4,000. 50,000. 50,000. This is the 10,000s place. We don't have a 50,000. We have a 40,000. Oops. Shame on me. That's supposed to be an X. Silly me. And that's an X. Do we have a 700? Yes. A 20? Yes. And a 9? Yes. So this part was good, but this part is bad, so we can't have C. Let's look at D. 40,000? Yep. 5,000? Yep. 200? Here's our hundreds. Do we have a 200? No, we have a 700. So that messed up this one. 20, yes. 9, yes. But that one little piece ruins the whole thing. So now that we've processed through all of the choices, which one matches ours? B. We had to do a little extra work on B, but it matches. Excellent job, mathematicians. Now it's your turn. Your time to try. You're going to answer this pop-up question. A number is represented in expanded form below. 60,000 plus 900 plus 40. What is this number in standard form? Use your strategies. Draw your place value chart. Plug in your digits based on the values to see what the number is in standard form. All right, good luck, mathematicians. Answer the pop-up question. All right, welcome back, mathematicians. Now we're going to represent a number in a different way. You'll notice it's kind of similar to expanded form, but with one big exciting difference. Expanded notation means you are decomposing a number showing the digit times its place value. Ooh, so we're throwing in some multiplication, but you really don't have to know your multiplication facts. You just have to know the value of each place. So we're going to use our place value knowledge to help us here. So let's take a look at our number 64,275. We know that our 6 is in the 10,000s place, which means it has a value of 60,000. In expanded notation, that is written as 6 times 10,000. Let me point you to down here where it's a little bit bigger. 6 times 10,000. I know that that looks really scary, big multiplication, but think of it this way. There's a 6 in the 10,000s place. See how easy that is? 6 in the 10,000s place is how you can read that. Let's try another value. We have a 4 in the thousands. That would be 4,000. And that is written in expanded notation as 4 times 1,000. Another way to think about that is there's a 4 in the thousands place. Let's take a look at our 2. He's in the hundreds. We know that's 200. So in expanded notation, that would be written as 2 times 100, or 2 in the hundreds place. 7 in the tens place is worth 70, and that is written as 7 times 10, or 7 in the tens place. And last, baby ones. Here we have a 5 in the ones place, which is worth 5, and that would be written as 5 times 1, or 5 in the ones place. So see, once you know how to read it and use your place value knowledge, expanded notation isn't as big and scary as it looks. All right, let's try some. Get your place value chart ready. Our question says a number is represented in expanded notation below. What is this number in standard form? Well, our strategy is the same as when we were taking a number from expanded form and putting it in a standard form. We're going to draw our place value chart and plug in our digits based on the values given. So let's look at the first part of our expanded notation. 3 times 10,000. Remember how we read that or think about it? 3 in the 10,000s place. That's easy. 3 in the 10,000s place. Let's look at the next part. 6 times 100. We can think of that as 6 in the hundreds. Ooh, I'm noticing something here. Are you noticing something? 4 times 1,000, or 4 in the thousands place. Did you notice what just happened? They mixed up our values here. They're trying to trick us. But they're not going to trick us because we know that we have our place value chart and can plug in our digits. So there's a 4 in the thousands. Then we have an 8 times 1, or 8 in the ones place. Well, here's our ones. Put an 8 there. What do you notice? Sneaky 0. Sneaky 0 in the tens place. Right there. Put in our comma. And now we have our number. Let's write that number in standard form. Let's say it as we write it. 34,000 608. All right, excellent job. So now, do you see an answer choice that matches exactly our digits written out in standard form? Look closely. Ah, B matches ours. Good job. They threw two tricks in us on this one. They mixed up the order of the values and they had a sneaky zero in the tens place. So they really tried to trick us on this one, but they didn't get us because we are smart mathematicians. Let's try this problem. Here, they gave us the standard form this time, and they want us to come up with the expanded notation, so they have flip-flopped it on us. But no worries, because we have our place value chart, we can do this. So the first thing that we want to do is draw our place value chart. Got it already, ready to go, and plug in the digits. Here's our number, 47,088. Let's plug that in our chart. You plug it in while I plug it in. Okay. And so now we need to go through and write it out in expanded notation. I'm going to be writing it out down here just because it's hard to fit it in the place value chart. So here we have a 4. So I'm going to start with my parenthesis group, 4. And I'm going to use my times sign and say in the, what place are we in? 10,000. So I'm going to write 10,000 and close up my parenthesis group. That's how easy it is. I'm going to write a plus sign and let's get ready to do the next value. We've got a 7, so parentheses, then 7 and my times. He says in the 7 in the, what place are we in? Thousands place. So I'm going to write 1,000 and close up my group. All right, let's keep going through our number. Do we have any hundreds? No. So do I need to write a parenthesis group for the hundreds? I don't. So now we can go to the tens. We have an 8 in the tens. So 8 in the tens. And last, we have another 8, but this time we've got him in the ones. So my last group is going to be 8 in the ones. And we did it! We just wrote out expanded notation. How cool is that? All right, so now that we have ours, we need to use little checks and little X's to figure out which one of theirs matches ours. So let me get out our pen. All right. Let's get ready to do little checks and little X's. A has 4 in the 10,000s, do we? Yes, we do. Check. 7 in the thousands. We do. Another check. 8 in the hundreds. Did we have any hundreds? No. Womp womp. That ruined that one. It did have 8 in the ones, but can't use it. Bye-bye A. All right, let's look at B. 4 in the 10,000s. Yep. 7 in the hundreds. 7 in the hundreds? Nope. Nope. We did have 8 in the tens, and we did have 8 in the ones, but not 700, so bye-bye B. Let's look at C. 4 in the 10,000s. Yep. 7 in the thousands. Yep. 8 in the tens. Yes. Ooh, this is looking good. 8 in the ones. Woo! All little checks. It matches ours, but are we going to stop? Nope, nope, nope. Can't stop, can't stop. We still have one more answer choice to process through. 4 in the thousands. Here's the thousands place. Do we have a 4 in the thousands? Nope. So that ruined that one. 7 in the hundreds? Nope. There's supposed to be 0 hundreds. This one's not very good. 8 in the tens? Well, we did have that. And 8 in the ones, we did have that. But bye-bye D. We did it. C matches our expanded notation. Give yourself a round of applause, mathematicians. Excellent job. Well, now that we have practiced together, it's your turn to try expanded notation. This problem is just like the one we just did, so use your strategies, draw your place value chart, plug in your digits, then write your expanded notation and use your little checks and little X's to help you process through the answer choices. All right, mathematicians, answer your pop-up question and have a wonderful day. Thank you for learning with me.